么这样吵哦？158 is sitting.
Okey. Okey, salam sejahtera dan selamat malam para penonton webinar di YouTube Live Magic Revisions. Okey, sebelum kita memula program kita, izinkan saya untuk buat sedikit penerangan ringkas mengenai program kami. Okey. Kami mengalu-alukan pelajar-pelajar Kolej Matrikulasi untuk menyertai program Magic Revisions #Go Digital Go Matriculations bawah anjuran bersama pensyarah cemerlang Kolej Matrikulasi Selangor dan Kolej Matrikulasi Johor. Saya, Puan Lim Hui Ching, merupakan moderator pada slot yang pertama ini, manakala Puan Nashima Hebi merupakan moderator untuk slot yang kedua. Untuk pengetahuan para penonton webinar, pasukan kami terdiri daripada 6 orang pensyarah dalam 4 bidang kepakaran berikut, iaitu matematik, kimia, biologi, fizik, yang merupakan 4 subjek teras dalam program matrikulasi 2 semester. Untuk makluman, program kami akan terdiri daripada siri-siri slot seperti berikut. Yang pertama, slot kami akan pada 20 November iaitu hari ini adalah slot kimia. Bermula dari jam 8.30 hingga 10 malam. Slot yang kedua adalah pada 27 November iaitu untuk khusus biologi dan fizik. Manakala slot yang ketiga adalah pada 4 Disember iaitu adalah untuk khusus matematik. Tujuan utama program kami dilaksanakan adalah untuk membimbing para pelajar Kolej Matrikulasi membuat persediaan awal dalam menghadapi peperiksaan semester program Matrikulasi 1 sempena musim pandemik COVID-19 di Malaysia. Oleh itu, kami akan berkongsikan tip-tip yang penting mengikut pengalaman mengajar kami dalam bidang kepagaran kami masing-masing. Untuk malam ini, kami akan menyediakan 2 slot pembentangan yang terbahagi kepada 2 sesi, iaitu sesi pembentangan dan sesi soal jawab pada setiap slot. Untuk makluman, semasa sesi pembentangan, tiada sebarang interaksi antara penceramah dengan pelajar. Jika pelajar ada sebarang pertanyaan, bolehlah tulis soalan-soalan di ruangan live chat YouTube. Jika masa mengizinkan, penceramah akan menjawabnya satu persatu semasa sesi soal jawab nanti. Okay. Ya, berikut merupakan penceramah kami untuk slot malam ini. Untuk slot 1, penceramah adalah Madam Tang Yun. Beliau adalah calon guru cemerlang kimia dari Kolej Matrikulasi Selangor. Tajuk pembentangan beliau adalah Stoichiometric Limiting Reagent and the Percentage Yield, manakala pada slot yang kedua, penceramah kami adalah Madam Chia Chuping. Beliau adalah guru cemerlang kimia dari Kolej Matrikulasi Selangor. Tajuk pembentangan beliau adalah Redox Titration involve balancing Redox equations and problem solving of Redox. Okay, pelajar-pelajar di saluran YouTube Live mesti tak sabar-sabar ingin menerima input daripada kedua-dua penceramah kami. So, harap pelajar boleh menumpukan sepenuh perhatian di sesi pembentangan, manakala sebarang persoalan boleh ditanya semasa sesi soal jawab dengan menaipkan soalan-soalan di ruangan live chat YouTube. Okay, dengan ini, saya mempersilakan penceramah yang pertama, iaitu Madam Tang Yun, untuk memberi perkongsian beliau.
So, good evening, all the students. So, I'm Madam Tang Yun from Kolej Matrikulasi Selangor. So, tonight I'm going to do some revisions with you all. So, the revisions that I'm going to focus on is on chapter 1.3, stoichiometry, and I will be focusing on how to determine the limiting reagent and also how to use the limiting reagent to determine the excess reactant left in a reaction and how to determine the product, and also going to revise on the percentage yield as well. So without further ado, I will start my presentations tonight. So my presentations tonight is going to be on 1.3 stoichiometry, focusing on the limiting reagent and also the percentage yield. So this is a wheelbarrow. So how to make a wheelbarrow? So basically we need a barrel and also a wheel in order to make a wheelbarrow. So now if we have 3 barrels and 5 wheels, how many wheelbarrows can we make? Yeah, the answer is 3 wheelbarrows. So how do you get this? So basically, the barrels here, is the limiting reagent. When all the barrels are used up, so there will be 3 wheelbarrows being produced. So what can we conclude here? So basically, the first thing about limiting reagent is when the limiting reagent are be completely used up, it will determine how much product will be produced in a reaction. So this is the first thing you must remember about the limiting reagent. So the limiting reagent will determine how much product will be produced in a reaction. So second, so just now we already know that the limiting reagent is the barrels here. Okay, so the barrels limiting reagent will also determine how many excess reagent the wheels are going to be needed in a reaction. Like for example, here we have the 5 wheels, but then when all the 3 barrels being used up, actually only 3 wheels is being required. So how many excess wheels is there here? So basically, there are 2 wheels in excess. So how do we get to these 2 wheels in excess? So basically, we just need to use the wheels given 5 minus the wheels needed 3 in order to get the 2 wheels in excess. So this is the second thing you need to remember about limiting reagent. So limiting reagent will determine how much excess reagent is going to be needed in a reaction. And then by knowing how many or how much excess reagent needed in a reaction, then we can calculate how much excess reagent left after a reaction. So for this, now shall we look at what is the definition of limiting reagent? So limiting reagent basically is the reagent that is completely consumed in a reaction. When it is being completely consumed in a reaction, basically it will determine how much product is going to be formed in the reaction. Okay. Besides this, limiting reagent will also determine how much excess reagent is needed. And from there, we can determine how much excess reagent is left in a reaction. So we have seen 2 things that limiting reagents is going to be to determine. First is the amount of product produced in a reaction. Second is how much excess reagent is going to be left after a reaction. So means that whatever, we need to determine the limiting reagent first in a reaction. How to determine a limiting reagent in a reaction? So very easy. So basically, there are 4 steps for us to follow through. So step number 1 is we need to determine the number of moles given for both reagents. So for chemical reaction, we need to compare in terms of number of moles. Because of that, in step number 1, we need to determine the number of moles given for both reagents first. Then in step number 2, after we have determined the number of moles given for both reagents, we need to determine the number of moles needed. So for this number of moles needed, we need a balanced chemical equation for us to know the stoichiometric relationship between the 2 reagents. Okay, then only we can determine the number of moles needed. So for step number 3, after we get the number of moles given in step 1 and the number of moles needed in the step 2, we can compare the 2 number of moles, and then in step number 4, we can draw a conclusion whether that particular reagent is the limiting reagent or not. when the particular reactant is the limiting reactant, then the partner will be the excess reactant. So now I give you the first example. So in this example, we want to determine which of these two reactants is the limiting reactant. So whether is the hydrogen sulfide or the oxygen. So how to determine whether which of these two is the limiting reactants? So we just need to follow through the 4 steps. So step number 1, remember, we need to determine the number of moles for the both reactants given. So here we are being given the mass of hydrogen sulfide and also the mass of the oxygen. So we are being given in terms of mass. But remember, to do comparison, we need them to be in terms of number of moles. That's why step number 1, we need to calculate the number of moles given for both reactants. So mass, how do we calculate the number of moles? Must remember, we need to use mass divided by the molar mass. Okay, we need to use mass divided by molar mass, and this number of moles is the number of moles given. Is the number of moles given because we calculate this number of mole from the mass given. So do the same thing for oxygen. Also, we use mass divided by the molar mass of oxygen gas to get the number of moles. So this 1.563 moles of oxygen here is also the number of moles given for the oxygen. So basically, this is step number 1, determine the number of moles given for both reactants. Then we move on to look at the step number 2. So in step number 2, we need to determine the number of moles needed. So how to determine the number of moles needed? First, we must look at the balanced chemical equation. So from the balanced chemical equation, we know the stoichiometric relationship between the two reactants. So basically, 8 moles of hydrogen sulfide will need 4 moles of oxygen to react with. And from the step number 1, we already get the number of moles given for hydrogen sulfide. So for this number of moles given for hydrogen sulfide, the number of moles of oxygen needed is just 0.4399. So this is step number 2. We use the balanced chemical equation to find the stoichiometric relationship, and then after that we determine the number of moles needed. So this is step number 2. So in step number 3, we need to compare the number of moles given with the number of moles needed. So this number of moles given, we already found in step 1. We already found in step 1. And the number of moles needed, we found this in step 2. So now come to step number 3, we just need to compare the number of moles given with the number of moles needed. Remember just now in step number 2, we were looking for the number of moles needed for oxygen. So because of that, now when we come to the step number 3, we need to compare in terms of oxygen. We need to compare the number of moles given for oxygen with the number of moles for oxygen needed. And from this, it is very obvious that the number of moles of oxygen given is greater than the number of moles needed in the reaction. So in step number 4, then we can draw a conclusion. So just now in step number 3, we already found out that the number of moles of oxygen given is more than the number of moles of oxygen needed. So this is the number of oxygen that is actually needed in the reaction. Can you see that it is way less than the number of moles given? Okay, so the number of moles given is too large compared to the amount of oxygen needed. So what conclusions can we make about oxygen? So means that oxygen here is the excess reactant because you only need this much, but then what is being given is way more than needed. So what can we conclude here? The oxygen is the excess reactant. So when the oxygen is the excess reactant, then the partner hydrogen sulfide will be the limiting reactant. So basically, these are the 4 steps you need to go through in order to find which of these reactant is the limiting reactant. So remember, limiting reactant, okay, can be used to find how much excess reactant left after a reaction. So now we move on to look at, so in this question, we want to determine how many grams of excess reactant left after the reaction. So remember, it's the limiting reactant that is going to determine how much excess reactant needed. So because of that, we need to use the limiting reactant, okay, to compare in order to find the number of moles of excess reactant needed. Okay, so to get the comparison, still we need to refer back to the balanced chemical equation. So from the balanced chemical equation, we know the stoichiometric relationship between the limiting reactant, hydrogen sulfide, and also the excess reactant. So can you see that from the balanced chemical equation, basically 8 moles of limiting reactant, hydrogen sulfide, require 4 moles of oxygens to react with. And given, so this is the number of moles of hydrogen sulfide given that we calculated just now. So with this number of moles of hydrogen sulfide given, actually the oxygen only required or only need 0.4399 moles. Okay, we only need 0.4399 moles of oxygen to react with this limiting reactant. Remember, limiting reactant will be completely consumed in the reaction. And when all of these limiting reactant being used up, actually only 0.4399 moles of oxygen is needed. But then, just now, previously in step number 1, we already calculate the number of oxygens given in the reaction. Okay, so this is the number of moles of oxygen given. But then, just now, we already calculate when all the limiting reactant hydrogen sulfide being used up, we only need 0.4399 moles of oxygen. This is only the amount needed, okay, when all the limiting reactant being used up. But then in the reaction, you have been given 1.563 moles of oxygen. So how to find the number of moles of oxygen left in the reaction? So basically, you just need to use the number of moles given minus the number of moles of oxygen needed. Then you will the number of moles that you get is the number of moles of oxygen left after the reaction. But the question wants in terms of mass, not number of moles. So after you get the number of moles of oxygen left, you still need to multiply it with the molar mass of oxygen to get the mass of oxygen left after the reaction. So I have shown you how to use the limiting reactant, okay, to calculate the amount of excess reactant needed, and then use the number of moles given minus the number of moles of excess reactant needed to react with the limiting reactant to find the amount of excess reactant left after the reaction. Okay, so besides determining the amount of excess reactant left, okay, so the limiting reactant can also be used to determine the amount of product produced in a reaction. So remember the definitions of limiting reactant. Okay, limiting reactant itself will be completely consumed in the reaction. Okay, and it will determine how much product is produced after the reaction. Okay, so just now we have determined the hydrogen sulfide is the limiting reactant. Okay, so from the balanced chemical equation, we can see that 8 moles of hydrogen sulfide, the limiting reactant, okay, will produce 1 mole of S8 liquid. So that is the stoichiometric relationship from the balanced chemical equation. So now, remember, this is the number of moles given that we calculate before for limiting reactant. So when this number of moles of limiting reactant being used out, so basically this is the number of moles of product being produced. Okay, but the question do not want it in terms of number of moles, they want it in terms of mass. So after you get the number of moles of the product, what do you need to do in order to calculate the mass? So again, the number of moles of product produced need to multiply with the molar mass. So this is the molar mass of S8 in order to give us the mass of S8 produced. So we have looked at the two things that can be determined by limiting reactant, the product and also the excess reactant left in a reaction. So now we move on to look at theoretical yield. So what is theoretical yield? So theoretical yield basically is the quantity of product calculated when all the limiting reactant is consumed. Okay, so when limiting reactant all is being consumed, the quantity of the product that we calculated is the theoretical yield. So for example, just now our limiting reactant is the barrels. Okay, so when all the barrels are being used up, so theoretically there are 3 wheelbarrows being produced. So this is the theoretical yield. The 3 wheelbarrows produced is the theoretical yield. Then what is actual yield? So actual yield is the quantity of product actually obtained from a reaction. Okay, so for example, so theoretically, when all of the barrels being used up, theoretically we will get 3 wheelbarrows. However, after finish producing the wheelbarrows, suddenly realize that actually one of the wheelbarrows is cracked, cannot be used. Okay, so then the actual yield is actually only 2. Then what is percentage yield? So percentage yield, so this is the formula for percentage yield. Okay, so percentage yield is equal to the actual yield divided by the theoretical yield multiplied by 100. Using the wheelbarrows as the example, so the theoretical yield is 3 and the actual yield is 2. So how do we calculate the percentage yield for the wheelbarrows? So we just need to substitute the actual yield 2 into the formula and theoretical yield 3 into the formula, multiply by 100, and the 66.67% is the percentage yield. So now, shall we move on to look at the example for percentage yield? So how do we calculate the percentage yield for these examples? Okay, so the question say calculate the percentage yield if 25.64 gram of S8 is obtained from the reaction. This 25.64 gram is the actual yield. From the reaction. Okay, and then in order to calculate the percentage yield, remember we need the theoretical yield. So still remember how to get the theoretical yield. We need to determine the theoretical yield from the limiting reactant. And in example 1, just now we already determined our limiting reactant is the hydrogen sulfide. Okay, and then from the balanced chemical equation, we can see the stoichiometric relationship between hydrogen sulfide and S8, the product. So basically, 8 moles of S8 will produce 1 mole of hydrogen, 1 mole of S8. So 8 mole of hydrogen sulfide will produce 1 mole of S8. So limiting reactant, so remember this is the given number of moles of limiting reactant. When these given numbers of moles of limiting reactant completely been used up, this is the number of moles of S8 that is going to be produced. And then when we multiply with the molar mass, so this is the mass of S8 that is going to be produced theoretically. So means that this is the theoretical yield of S8. We get this from the limiting reactant. That's why this is the theoretical yield. So how do we calculate the percentage yield? Remember, our goal is to calculate the percentage yield. So how to calculate the percentage yield? So we just need to substitute it into the percentage yield formula. So the actual yield here is the 25.64 gram. And the theoretical yield is the one that we deduce from the limiting reagent, 28.24 gram. So, and then multiply by 100. So the 90.79% is the percentage yield of this reaction. Now we move on to example 2, another example on limiting reagent. So shall we have a look? Okay, so sometimes from the limiting reagent, we can also determine the actual yield if the percentage yield is being given. Okay, so how do we do this? Okay, so remember, to determine actual yield, we need to have the percentage yield. But to get the percentage yield, we also need to have the theoretical yield. Remember, we want to know the actual yield. Given percentage yield means that we need to know the theoretical yield. So still remember how to get the theoretical yield. Theoretical yield is obtained from the limiting reagent. But from this question, do we know ammonia or nitrogen, ammonia or oxygen gas? So which one is our limiting reagent? So we do not know. So means that in order for us to get the theoretical yield, first we must determine between ammonia and also the oxygen gas, which one is the limiting reagent first. So remember how to determine the limiting reagent? So there are 4 steps. So we need to go through the 4 steps first to determine between ammonia and oxygen, which one is the limiting reagent first. So still remember, first step, we need to calculate the number of moles for both reagents, our ammonia and also oxygen. So how to calculate the number of moles? We are being given the mass. So having the mass, how do we calculate the number of moles? Again, we need to use the mass divided by molar mass to get the number of moles. So this is the given number of moles of ammonia. Then how do we determine the number of moles of oxygen? Also the same thing, mass divided by the molar mass. So mass divided by the molar mass, so we get the number of moles given for the oxygen gas. So after we get the number of moles given for both reagents, then we can move on to step number 2. So still remember, in step number 2, we need to determine the number of moles needed. For that, we need to have the balanced chemical equation. So in this question, the question say ammonia react with oxygen. So ammonia react with oxygen, produce nitrogen gas and also steam. Okay, so when we have the balanced chemical equation, then we will know the stoichiometric relationship between the two reagents. So can you see that 4 moles of ammonia basically need 5 moles of oxygen to react with. So from step number 1, this is the number of moles given for ammonia. Okay, when 0.1176 mole of ammonia is being reacted, only 0.1471 moles of oxygen needed. Okay, so 0.1176 mole of ammonia will need 0.1471 moles of oxygens to react with. So this is step number 2. We get the number of moles needed. Then in step number 3, so we can compare the number of moles given with the number of moles needed. So in step 1, we already calculate the number of moles given. And in step 2, we calculate the number of moles needed for oxygen. Can you see that the number of moles of oxygen needed is greater than the number of moles of oxygen given in the reaction? So after we know that the number of moles given is less than the number of moles of oxygen needed, then we can come to step number 4 to draw a conclusion. Okay, so based on the step number 3 just now. So in step number 3, we know that the number of moles of oxygen given is less than the number of moles of oxygen needed. Can you see that we need more? We need more, but what is being given is less. So what conclusions can we make? So it means that oxygen here is the limiting reactant. Okay, it is the limiting reactant. And the partner, ammonia, is the excess reactant. So we haven't finished yet. Remember, our goal is to get the actual mass. After we get the limiting reactant, then we can determine the theoretical yield. So how do we determine the theoretical yield? So still remember, limiting reactant, our limiting reactant now is oxygen. Limiting reactant will determine how much product is being produced. So our product here is nitrogen monoxide. So from the balanced chemical equation, we know that 5 moles of oxygen will produce 4 moles of nitrogen monoxide. And when so this is the given number of moles of oxygen. When all of these given numbers of oxygens is being reacted, this is the amount of nitrogen monoxide will be produced. The questions were in terms of mass. Okay, so what we need to do is we need to multiply with the molar mass of nitrogen monoxide in order to get the mass of nitrogen monoxide. The mass here is the theoretical mass. So how to know this is theoretical mass? We know this is theoretical mass because this is the mass deduced from the limiting reactant. It is the mass that deduced from the limiting reactant. Therefore, this is the theoretical mass. So our goal still not reached yet. We want to calculate the actual mass. We get the theoretical mass already, and we have the percentage yield. So how do we determine the actual mass? So we just need to have the percentage yield formula, and then we substitute the percentage yield and also the theoretical mass into the formula to determine the actual mass. Okay, so this is the actual yield and the actual mass of nitrogen monoxide produced if the percentage yield is 95.6%. So again, in order to get the theoretical yield, we must determine it from the limiting reactant. Okay, so this is example 2. So now move on to the last example. So students always confuse. Okay, sometimes always confuse whether that particular question is about limiting reactant or not. So if you realize that, so for limiting reactant types of question, informations will be given for both reactant, in order for you to determine the number of moles for both reactant. Okay, so in example 3, so this is not limiting reactant type of question. Why? Because in this question, okay, so in this question, so basically only one information is being given for one of the reactant. So our reactant here, so in example 3, we want to prepare silicon tetrachloride liquid from chlorine gas and also silicon solid. So the chlorine gas and also the silicon solid are the reactants. But can you see that information is only given for one reactant, which is chlorine. So means that for this question, you do not need to determine the limiting reactant. Okay, it is different from the limiting reactant type of question. Limiting reactant type of question, again, information will be given for both reactant. So you can calculate the number of moles for both reactant. But for this example, can you see that information is only given for one reactant? So means that this is not limiting reactant type of question. So if this is not limiting reactant type of questions, so how do we solve this question? So still the same. So step number 1, you calculate the number of moles, but you only calculate the number of moles for one reactant because information only given for one reactant. Okay, so this one is being given in volume, and they give you the room condition. So means that to calculate the number of mole, you just need to use the volume divided by the molar volume at room condition to get the number of moles of chlorine gas. And in order to calculate the product, you still need to have the balanced chemical equation so that you know the stoichiometric relationship between chlorine gas and also the product. So from the balanced chemical equation, you know that 2 moles of chlorine gas will produce 1 mole of liquid silicon tetrachloride. So with this number of moles of chlorine, this is the number of moles of silicon tetrachloride that is going to be obtained. But the question, one mass. So how do we calculate the mass? So in step number 3, the number of moles of silicon tetrachloride that you get, you just need to multiply with the molar mass to get the mass of silicon tetrachloride. So for this question, you do not need to determine the limiting reactant because you are only being given one information to determine the number of moles for one reactant. So you don't need to determine the limiting reactant. Okay, so now I want to conclude what I have covered with you tonight. So first, I cover with you the 4 steps to determine the limiting reactant. So remember, step number 1, you need to calculate the number of moles for both reactants. And then step number 2, based on the balanced chemical equation, you know the stoichiometric relationship between the 2 reactants, then you can calculate the number of moles needed. So in step number 3, you compare the number of moles given in step number 1 with the number of moles needed, you determine in step number 2. After you compare in step number 3, you can make a conclusion whether that particular reactant is the limiting reactant or the excess reactant. That was the first thing that I covered with you. And the second thing is limiting reactant can determine the amount of product produced and also the amount of excess reactant left after a reaction. For this, remember, you need to use given number of moles for limiting reactant in your calculation. You must use the given number of moles of limiting reactant that you determine in step number 1 to determine the number of moles of product and also the number of moles of excess reactant to be reacted with. You need to use given number of moles. And then I also cover theoretical yield and actual yield with you. must remember theoretical yield is the yield that you determine from the limiting reactant, from the given number of moles of limiting reactant. You determine the theoretical yield. And the actual yield is the yield that actually obtained from the reaction. And then I cover percentage yield with you. So remember the formula for percentage yield is actual yield divided with theoretical yield multiplied by 100. And the last one is, okay, I taught you how to differentiate whether the question is limiting reactant type of question or not. Okay, so now I give you two questions, the one in red and the one in yellow. Can you tell me which one is the limiting reactant type of question and why? Okay, good. The yellow one is the limiting reactant type of question. Why? Because information are being given for both reactant and you can determine the number of moles for both reactant, your benzene and bromine. So because of that, the yellow one is limiting reactant type of question. So in order to determine the product, first you must determine the limiting reactant first. Between benzene and bromine, which one is the limiting reactant? Okay, so basically that's it for my presentations tonight. Hope you all learn something from me tonight. So now we go back to studio with Madam Ling.
Okay. So terima kasih kepada Madam Tan atas perkongsian beliau sebentar tadi. Okay, harap-harap pelajar dekat live studio boleh faham dan menguasai kemahiran macam mana nak menyelesaikan masalah yang berkaitan dengan limiting reactant dengan hanya 4 simple step yang dicadangkan oleh Madam Yun tadi. Okay, so kita pergi ke sekarang kita sampai ke sesi soal jawab. Okay, saya tengok dekat ruangan live chat ada beberapa soalan yang dia nak kemukakan kepada Madam Tan. Okay, wait Okay, the first questions yang dia ada tanya kuat berapa kali adalah yang ini. Dari pelajar Tan Yanju. Answer to how many decimal places?
Okay, so to answer the question for chemistry, we are not looking for decimal places. We are looking for significant figures. Throughout the calculation, you need to give your answer in 4 significant figures. 4 significant figures, not decimal places, okay? Not decimal places. We look for significant figures. 4 significant figures.
Okay. Boleh?
Okay.
4 significant figures. Okay, soalan yang kedua adalah yang dari Hong.
The actual value, yes. Usually the actual value will be smaller than the theoretical value. Why? Because theoretical value is the theoretical value, theoretically what you will get. But during the experiment, what you get is the actual value. So during the experiment, you have done many experiments. So you know that during the experiment, a lot of things can happen. Your product can fly here, fly there, stick here, stick there. That's why actual yield always smaller than the theoretical yield.
Okay.
Because during the experiment, accident happened. Okay.
Okay. Ada satu lagi. Yeah, wait. Very long questions. Wait.
Okay.
Okay. This one.
Or less than.
How only one of the mole?
In step number one, you do not know which one is the limiting reactant yet. So if you do not calculate the number of moles for both, you can't do the comparison in step number 3. So if you can't do the comparison in step number 3, you won't be able to know which one is the limiting reactant. Because you need two to compare. If you only have one, you can't compare. Okay, are you clear, student Connie?
Clear? Okay. Wait, ada satu lagi. Okay, this one. Connie jawab.
Yeah, you need to, instead number one, you need to calculate the number of moles for both reactant. Yes, you need to. Okay, because if not, if you only calculate one, instead number 2, you only get the number of moles needed. So if you get the number of moles, like for questions just now, you get the number of moles needed for oxygen. But if you don't calculate the number of moles given for oxygens in step number 1, you cannot compare between the number of moles given and the number of moles needed for the oxygen. So if you can't compare between two of them, you cannot come to a conclusion whether the oxygen is the limiting reactant or excess reactant. So you need to calculate both number of moles in the first step.
Okay. Wait, another wrong question is this.
Okay. Interval must be the mass. No, not necessarily be the mass. It can be in terms of number of mole. But if in terms of number of mole, means that for the actual, if the question gives you actual mass, you need to convert it to number of moles first. Means that for the theoretical yield and also the actual yield, you do both in number of moles. If you do both in number of moles, then it's okay. If not, then you need to do both in mass. Basically, to calculate the percentage yield, theoretical yield and actual yield must have the same unit. So if you do it in moles, both in moles. If you do it in mass, both must be in mass.
Okay. Okay, hopefully faham lah. Okay, clear? Okay. A lot of questions everywhere. Okay. So that's why is do both in order to get full marks.
So what is the both means? You need to tell me more explicit. What does your both mean?
Wait tengok dia ajak.
Sure, you need to tell me what does your both means.
Okay. Next topic is
Still a lot of questions.
no, wait.
Okay.
Chong didn't answer. Wait, I find another question first.
Not clear.
Not clear. Remember, we proceed to next question first.
Okay. So if the question give you the hint somewhere, whether it's liquid, aqueous, gas, then you need to include. If the question already telling you what are the state of the matter, then you need to include for the reactants and products. Okay, so like the questions that I gave just now, stated there liquid, solid, then you must include it in your chemical equation.
Okay, the next question is to do a table.
Yeah, if you think the table is easier for you, yes, you can do in table form. But instead number 2, the stoichiometric relationship and the comparison, you still need to show the calculation. You still need to show the calculations on how you get the needed number of moles somewhere.
Okay, saya rasa yang ini he help Chong to answer.
Okay. Yeah. In step number 1, you need to calculate the number of moles for both reactants. if you don't calculate the number of moles for both reactant, you can't do the comparison in step number 3. If you can't do comparison, you cannot come to a conclusion whether that particular reactant is limiting reactant or not.
Okay, so another one is this.
Is there any scale for the answer? We obtain different final answer like 0. But the example that you give 0.983 and 0.0984 is very different. I think you mean 0.983 and 0.984. If the difference between is just 0.001, that is acceptable. Okay, it's not 0.0984, right, Ruba? I think it's not 0.984, right? You mean?
Different, right?
Yeah.
So different. Maybe it's 0.984.
Yeah. So if the difference is just 0.001, it's okay. It's okay.
Okay, so another question is this.
Okay. Oh, this is very different. Significant figures and decimal places is very different. Okay, so like the Ruba's questions just now, even though Ruba's question just now is three decimal places, 3 significant figures and 3 decimal places, but significant figures, if you are not sure, you can write in terms of standard form. Standard form means that you can write 4 number times 10 to the power of something. Then definitely you get 4 significant figures. Are you all clear?
Okay.
You can write in standard form.
Okay, I think ini adalah no, this. Just now you say it's the type. No, I mean it's the just now the 0.8 843.
Okay. It's okay. I get your questions.
Yes, that is the. I think it's the. We should as the last questions because already 8:30. Percentage you must be in.
This is my student. Cairo Iquan. Ya, betul. Percentage you mesti dalam percentage.
Yeah. Okay. I think basically. Okay, understand. Okay. Clear, madam. Okay, understand. Okay, I think for the Q&A section, we should stop here lah because we have another slot. Okay, thank you very much for Tang. Okay. Okay, now I proceed. Okay, I handle. Okay, for the second slot for the Madam Shima and Puan Chia.
Selamat malam pada pelajar-pelajar. Okey, tahniah. Okey, anda terfikir untuk masuk belajar bersama-sama hari ini. Bagus respon pelajar-pelajar semua. Okey. Terima kasih kepada Puan Iyun just now. Okey, Puan Iyun sebenarnya pensyarah daripada Kolej Matrikulasi Selangor. Okey, tanpa kita buang masa, okey, so kita ada lebih kurang 45 minit lagi. Slot seterusnya kita bersama Madam Chia Chuping, juga merupakan pensyarah daripada Kolej Matrikulasi Selangor. Okey, tajuk yang beliau akan bincangkan adalah Redox Titration involve the balancing, Redox equation and problem solving. Okey, jadi kita akan ada sesi pengajaran dulu dan di akhir nanti kita akan ada sesi soal jawab. So pelajar boleh communicate masa tu ya. So tanpa buang masa, kita persilakan Madam Chia.
So good evening to my students. So my name is Madam Chia. So tonight
our objective for learning of title is a redox titration, where it involves the balance equation, balance redox equation, and calculate the percentage yield of the iron sample. Okay, now, so I share my slide first. Okay, so redox titration, right, we understand is talking about the oxidation and reduction reaction. So, under this topic, right, student must able to balance redox equation. So where's redox equation divided by 2? First is in acidic condition. Second one is in the basic condition. So the next part is we were talking about application. So meaning that we're using the redox equation to calculate the percentage of pure iron of a sample. Okay, so welcome to the this channel. So we'll try to I will try to share my idea about the title redox equation. Okay, come. So this is my slide. Okay, so you can, this is before we start the balance redox equation, so I give you the 5 basic steps to balance redox equation, where you learn in August, right? Chapter 1, end of chapter 1. So come we join the game. So how refresh your memory, how to balance redox equation. So you can scan the QR code, or you can search the link, World link at the chat room. Okay, so I'll give you around 4 to 5 minutes. You play first, then I will play together and we'll do how's your result together. Okay, come. All right, so students, so this is a result I get from the response from students. So whereas now is 51 students, so they try to answer. Okay, you can see the first ranking one is LOLL, second one is Danish, the third one is Pamo. Oh yo, the name was so special, right? Okay, so you can see how many students correct and incorrect. Okay, never mind. So now I think you already know the answer, how to arrange it. Okay, now I play together with you. So how about the 5 step, the basic 5 step to balance the redox equation? Okay, come. Okay, now so before we start the lesson today, we try to enjoy and refresh our memory how to balance the redox equation with the basic 5 step. All right, first one. So they ask you to balance the 5 step. Okay, the first step is you must the first step is we will balance balance atom other than OH. Meaning that the atom is no O, is no H. Example, we can balance the Cr, we can balance Mn, chromium ion, as long as not the O and the H. So this is our first step. Okay, how about second step? Second step followed by O. So we balance the O by using the H2O. Okay, now since we balance the O by using the H2O, meaning that now we have extra H. So how we balance the H? So the third step is balance the H by using the H plus. Okay, this is the third step. So after that, we will count the charge. We will count the charge for each species. Then we balance the charge by using the electron. Yeah, so this is step number 4. So last one is, in the law of conservation of a mass, number of electron gain is equal to number of electron loss. So you must make sure same number of electron for both equations. All right, can we check the answer together, class? All right, okay, so hopefully the game will help you to refresh your memory how to balance a basic redox equation. Okay, now I go back to my slide. Okay, so I start sharing my slide. Okay. So this is just as again, so you can refresh your memory. Okay, now we learn about how we solve the problem. All right, come. So hopefully you enjoyed the game. Now we go to study about the question. From the question, right, we'll balance redox and we'll short problem solving. Okay, first sentence is a 3.9 gram of a sample iron ore. Okay, this one dissolved in the acid and all the iron is reduced to the Fe2 plus ions. Okay, so what is iron ore? So this iron ore. So iron ore is a rock or mineral metal which contain the two things. First one is a pure iron. Second one is a impurity. The impurity can be anything. So that means iron ore contains two major things: pure iron and the impurity. So now I add the dissolved acid, 3.9 gram, include the ions and the impurity. I add the acid. So once I add the acid, right, so the iron solid will become the iron 2 plus. Then the balance one here is impurity. Right, so this is an acidic condition. How I know? Because I add the acid in the iron, so become the iron 2 plus. Okay, now after you understand the first sentence, now we focus to the balance one. The solution is then titrated with 0.2 molar potential dichromate, producing Fe3 plus and chromium 3 plus. So if a 42.10 ml of potential dichromate solution required to titrate the Fe2 plus solution, what is the percentage of iron in the ore? So the reaction is given here. So this reaction is a redox reaction which is unbalanced. Okay, before that we try to understand what happened now. Okay, so this is a process of titration. So by using the potential dichromate. So at the same time, once the reaction titration happen, so the Fe2 plus will change to Fe3 plus. Then at the same time, dichromate ion will form the Cl3 plus ion. So this is called redox reaction. So that one will recognize which is reduction and which is oxidation. Okay, after that, we will titrate until when? Until all of Fe2 plus in the solution complete react with the sodium dichromate. So meaning that the point is an endpoint achieved. So you can see the changing of color from the indicator. So at the endpoint, right, what is amount of that potential dichromate needed is 0.2 molar and 42.10 ml. So meaning that all the iron in the sample already react with the sodium potential dichromate. Yeah, so the left one is impurity, where the impurity is not react with the potential dichromate. So now you understand the question already. So first step, we will balance the redox first to solve the stoichiometry. Okay, come. So as you know, balanced redox equation is using the ion electron method and two conditions. The first condition is acidic condition, and the second one is a basic condition. So as you know, just now I add the acid to the Fe, right? So that means this is an acidic condition. All right, come. So we refresh your memory how to balance the redox equation one by one. Okay, this is an overall equation which is unbalanced. So what is the first step is we balance we divide by two half fraction. So how you recognize the two half fraction is you can find the same species at the both side. So let's say Fe2 plus Fe3 plus one pair, chromate Cr and Cr. So this is another pair. So after that we recognize you spread become 2. Yeah, so you spread become 2. Okay, now we'll solve the problem, balance it one by one. Okay, now this is what we played just now. First one is a balanced atom. Balance. See, this is a balanced atom other than O and H. That means now we check Fe, one Fe on your left and another Fe on your right side. That means Fe is a balance now. Okay, now for O, right, we don't see the O. We look at the other than O and H. Okay, now you can see the Cr is 2, but the Cr on your right side is 1. So I should put the 2 more of Cr on your right side. So now we settle step 1. Step 2, right, I will balance the O by using the H2O. Okay, now for first equation, iron 2 plus to iron 3 plus is no more O. So never mind, just copy and paste. So they didn't change anything. But how about second equation? Okay, for second equation, you can see contain the 7O in the equation. That means that we must balance the 7H2O on the right side because O is on your left side, means the 7H2O on your right side. Yes, 7H2O on your right side. Okay, now we proceed to the third step. So third step is a balance the H by using the H plus. Okay, now you check the first equation, Fe3 plus, don't have any H, so you just remain the equation. Now we check another equation, 7 times 2 equals to the 14H, meaning that you must make sure 14H also on your right side. Left and right must same number of the H. So I put on your right side, left side. So 14H plus. Right, okay, now it's a charge. So we must balance the charge by using the electron. Okay, now I show you. So before we balance the charge by using electron, right, student must able to determine how many charge for the left and right. Then you will know how to balance it. Okay, now we start with the 2 plus. The charge is a 2 plus for iron 2 plus, and the charge for Fe3 plus is a Fe3 plus. Now we must put the electron to balance both sides. Okay, I want to remind you again, electron is a -1. Electron is a -1. So the tips to balance the redox is first one, you will put the electron at the more positive side. So now you check +2 and +3. +3 is a more positive, so I should put the electron on my right side. So how many electrons you should put, right? So its answer is a 1. Why? Because 1 electron equals to -1. So 3 minus 1 equals to +2. At the end, the number of electrons is the same at the both sides. Okay, logic, right? So why we must put electron at more positive side is because electron is a -1. So if you put on your more positive side, right, so larger number will minus a smaller number, you become the small number. So you equals to 2. So if you put on your left side, right, you will see like the number becomes smaller. It's impossible balance it. Okay, this is the first tips. Second tip, right, is if you no idea how to balance it, right, you can do like this. So this is a 2. And then equals to 3. So you know electron must put on your right side. So you put the X. So 2 minus 3 equals to X. So -1 equals to X, meaning that X equals to the 1 electron. So this in case no idea and maybe the number is too big, right? You can apply the algebraic method to solve the problem. Right, okay, now, so we settle the first one. So that's why the ion, you will balance the 1 electron on your right side. Okay, now how about second equation? Now we calculate the charge one by one. So normally, this is a H plus, the charge is a plus 1. But since content 14, that means plus 1 times 14, you will get positive 14. So this is how we calculate the charge. Okay, second one is a dichromatic ion. So you must circle, this is a species with the charge -2. So meaning this is a -2. Circle the species, the outside is a -2. Second one is a chromium. Chromium is a 3 plus, but don't forget 2 more of chromium 3 plus. That means 3 times 2. So you get a 6. So this is how we calculate 6. So how about water? Water is a neutral. So meaning that the water is a 0. So now I will calculate how many electrons on my left side and the right side. 14 minus 2 equals to positive 12. 6 plus 0 equals to the positive 6. Okay, now I will balance the electron we put on your side, which is a more positive. Okay, now student, look at here. Left is a 12, right is a 6. Okay, try to guess which part you should put the electron, left or right. So the answer is left side, because left side is more positive. How many electrons to balance it? The answer is 6. So you can double check again. 6 electron meaning that equals to -6. So 12 minus 6 equals to positive 6. Okay, now positive 6 on your left and positive 6 on your right side. So now it's a balance already. Okay, that's why the answer will become 6 electron on your right side. Okay, students, so you know redox reaction is one equation will lost electron, another equation will gain electron. So meaning that once you balance the electron, so double check again. Okay, this one on your right side or this one on your left side. Okay. But if your electron is both on your left or both on your right side, there means something wrong with your equation. You must recheck again what's going on. Right, okay, now so we balance the number 4 already. Okay, now we go to number step. The next step is we must make sure same number of multiple integer must be, meaning that number of electron lost is equal to number of electron gain. Okay, now we check. So for the Fe2 plus, right, they will lost 1 electron, and the dichromatic ion will gain 6 electron. We must make sure both equation is the same number of electron. For this case, it's a simple. You just multiply 6 for the Fe2 plus, Fe3 plus equation. But if you get 2, equation number 1, 2 electron, equation number 3, equation number 2 is 3 electron. So how you do it? You just equation number 1, 2 times 3, equation number 2, 3 times 2. So you get the same number of electron. All right, now, so the next step is we will combine the 2 half equation because become the 1 equation. So how we do it is, before that, you must understand or determine which is a reduction and which is the oxidation. So to determine reduction oxidation, right, okay, got 2 methods. First one is oxidation is oxidation number will increase. Reduction is the oxidation number will decrease. The second method is oil rich. Remember the oil rich. O means oxidation, L means lost electron. So what I mean by lost electron is A plus produce B, and the electron on your right side, it means lost electron. Second one is rich, RIG. R stands for reduction and G stands for gain electron. So what is meaning by gain electron is A plus electron become B. So this meaning like gain electron. So this meaning lost electron. So this is another method to recognize which equation is a reduction and which equation is oxidation. All right, okay, now you can see for iron, right, I already multiplied by 6. This one is a loss. Loss means this is an oxidation. Make sure you label oxidation. And this one is a reduction. We call the gain. Gain. So this is a reduction. Okay, now I want combine become the two equation become one. The concept is if on the left and right side we can cancel or get the balanced one. So left and left side we will combine together, and the right side we can combine together. All right, now you can see on my left side is contains 6 electron, and right side is a 6 electron. So meaning that we can cancel the electron. So other than that, you can check any same species happen on your left and right side. So no. So no meaning that you can combine this electron, this species on your left side, and then you can combine all the species here on your right side. So this is a balanced equation for the redox equation. So of course you can put the phase because you can balance here. Okay, now so after we balance the redox equation, right, we'll analyze the equation. Okay, come. Okay, so this is a stoichiometry. It's from the balancing redox. Okay, now before we start the calculation, right, we try to analyze what the information they give you, and you can predict, you can plan what is your step by step. Okay, first one, T. So what is meaning by T? Usually I will put the symbol T. T is a stand for mole. So here is a theory. Sorry, T is stand for like theory. Theory stands for the how many mole from the stoichiometry, from the equation. For dichromate ion is 1 mole. For iron 2 plus is 6 mole. Okay, this is the first one, theory. Second one is a given. Given is what is information they give you. Okay, let's say for dichromate ion, they give you 42.10 ml and 0.2 molar. And the iron 2 plus, they give you 0.9 gram per iron ore. Okay, now, so student, after you analyze T and G, right, you must able to plan what is your step by step. Okay, usually, right, student will think about, okay, so, okay, student maybe will think about 3.9 gram as the mass. Okay, so maybe student will think about calculate the mole from the iron ore and get the mass something. So is it correct we calculate the mole from iron ore? Okay, let me show you. Is it correct or not? So let's say students start from the mass of iron ore. So they calculate the mole of iron is a mass of iron ore divided by the molar mass of iron. So they substitute 3.9 gram over 55.9 gram per mole. So they'll get 0.070 mole iron. All right, okay, now. Oh, okay, so mass of iron ore, right, don't forget, is contain the pure iron and the impurity, meaning that 3.9 gram, is contain the pure iron and the impurity. So when we divide by the molar mass of iron only, actually is not accurate. The more you get is not accurate, it's not stand for the more iron only. So meaning that this is a wrong method. So usually this is a common mistake, students. So don't use the impure mass to get the mole. So this is the first method, first mistake. Okay, now, so how we determine the mole of iron? Okay, now we look at what we're doing just now. How we determine the mass of pure iron is using the titration. So with the titration, right, you undergo redox reaction. So once undergo redox reaction, right, only pure iron, so Fe2 plus will react with the sodium dichromate. Meaning that only pure iron was react with the sodium dichromate, where impurity is not react with the sodium dichromate. So meaning that we're using the information for the potassium dichromate to determine the more of the iron 2 plus. Okay, so this is a concept of the problem solving. Okay, now, so we go back again to analysis. T, theory, 1 mole dichromate ion react with the 6 mole of the Fe2 plus. This is a theory from Stoichio. Given is 42.10 ml 0.2 molar dichromate ion and the 3.9 gram of iron ore. Okay, just now I said cannot calculate more of iron ore, right? Okay, what I should do? So first I will calculate the mole of dichromate first. Then stoichiometry, find the mole of Fe2 plus. Then okay, I can get the mass of Fe. Then so I can substitute the formula mass of iron in the sample divided by mass of sample iron ore, so times 100. So I will get the mass, I will get the percentage mass of iron. So this is a analysis of the question. Okay, now we go to step 3, where is determine the mole of a dichromate ion. So step 3 is to calculate the mole of a dichromate ion. Okay, so since they give you the molarity and volume using the MV over 1000. Okay, so we refresh your memory. Molarity equals to mole of solute over volume of solution in liter. So you want to calculate the mole of solute, that means mole equals to the molarity times volume in liter. So this is another formula, MV. So if a student want to write MV, make sure the unit is a liter. So once you're using MV over 1000, meaning that your volume is a ml. So ml divided by 1000, you'll become liter. So this is a basic concept from the formula molarity, mole of solute over volume of solution. So MV over 1000, so if using MV over 1000, if using MV over 1000, make sure you're using the ml. If you're using MV, make sure the volume unit here is in liter. In liter. Okay, liter. Okay, now, so we substitute all the information here. So I get the answer 8.42 times 10 minus 3 mole. So this is a mole of the dichromate ion. Okay, now I want to determine mole of Fe2 plus. In the previous slide, I show you we do stoichiometry to get the answer. How to write the stoichiometry? First step, we will write the theory. 1 mole dichromate ion with the 6 mole of Fe2 plus. So react with 6 mole Fe2 plus. So this is the first statement from the theory. Second statement is from the given. What they give you is this one, right? So 8.42 times 10 minus 3 mole. So 8.42 times 10 minus 3 mole dichromate ion can produce how many mole of Fe2 plus? So how we write the answer is 8.42 times 10 minus 3 mole times. Okay, so now you can see you want the final answer is Fe2 plus or dichromate ion. So if you, the answer is I want the answer, final answer in iron 2 plus. So this one I will put the iron 2 plus, and the bottom one I will put the 1 mole of dichromate ion. So why? Because at the end, right, you can cancel the mole of dichromate ion. Your final unit is a mole of iron 2 plus. So this is answer I will get 0.05052 mole iron 2 plus, right? But maybe students were confused. Teacher asked me to calculate Fe, but at the end I get the Fe2 plus. Okay, still remember the previous one. So we get the Fe, then we add the acid to form the Fe2 plus, right? So meaning that 1 mole Fe is equals to 1 mole Fe2 plus. So if I know the Fe2 plus is 0.05052 mole Fe2 plus, that means we can know the mole Fe also 0.05052 mole Fe. Yeah, so you can using the 0.05052 mole Fe to calculate the mass. Okay, now let's go. We go to step number 5. So step number 5 is to calculate the mass of the iron. So a formula is mole equals to mass over molar mass. To calculate the mass of iron is mole times molar mass. Okay, so mole times molar mass. So the answer I get is 2.8241 gram iron in the sample iron ore. So meaning that we can do analysis where is iron ore 3.9 gram. So pure iron only 2.8241 gram, but impurity, the balanced one is an impurity. Okay, now we can calculate the how many percent of pure iron in the iron ore. Okay, so you can calculate the percent already. So from the data I give you already know 2.8241 divided by 3.9 times 100, right? So this is the simple method. You can know how to calculate the percent. Okay, last step. So last step is once I get the mass of iron, now I will calculate the percent. So percent mass of iron equals to mass of iron in the sample divided by mass of sample iron or times 100%. So you get the answer 2.8241 gram divided by the 3.9 gram. So you get the answer is 72.41%. So meaning that in the iron ore sample I give you 3.9 gram, only 72.41% is pure iron. The balance one is impurity. All right, class. So now students, so now we finish about the slide already. So at the end of class, now you already know how to balance the redox equation for acidic condition. The first one. Second one is you already know how to analyze the equation where is involved the iron ore. Right. So you know how to analysis, you know how to plan, you know how to do the stoichiometry. Right. Okay. So thank you.
Okay, thank you to Madam Chia. Okay, penerangan yang sangat-sangat jelas ya. Alright, so redox titration. So 6 step dalam balancing the redox equation dan Madam Chia juga berkongsi beberapa tips yang boleh pelajar-pelajar gunakan semasa menjawab soalan nanti. Okay, diharap perkongsian ini sangat membantu pelajar. Jadi kita buka peluang untuk pelajar ingin tanyakan soalan. Okay, so soalan daripada Alan Tang.
Why I tried to measure temperature of steam in the A, but the temperature was only 38 degree. Can you explain more detail about this? Is it the steam already achieved the boiling point? So if achieve boiling point, usually is a higher temperature. Yeah. Okay. Okay, maybe Reactant can explain more detail about this question.
Okay, so kita harap Alan tolong ulang balik soalan dengan jelas, kita jawab. Alright, soalan seterusnya, okay, saya reset dulu. Okay, kita tengok soalan kedua. Okay, daripada Kai Kim Minji.
Alright, so can you help me to how to categorize them, especially for question Cl2, ClO4 minus plus Cl minus. Oh, okay. For this equation, right? Okay, so first half fraction is Cl2 to the ClO4 minus. This is the first equation. Second half equation is Cl2 to Cl minus. Okay, so I repeat again. First equation for the first half equation is Cl2 becomes ClO4 minus. Second equation is a Cl2 from the same reactant becomes Cl minus. Okay, then you can balance it as usual.
Alright, so kita tengok soalan seterusnya, Nurul Amira.
Okay, yes, it's compulsory to write the oxidation and reduction at the equation. Yes, compulsory.
Okay. Okay, so soalan seterusnya, Tio Wenyi.
Okay, so usually like I more emphasize the for the beginning you learn it's better you put the unit so that avoid the mistake or you ml liter like the PV goes to NLT, the R unit, anything, right? In the early stage you can put the unit, but we more emphasize the unit at the last steps. So last final answer, right? You must put the unit together. Yeah, if you put the unit at the solution, right, it shows it help you to more understand. But we more emphasize the unit at the last step, the last answer. Yes.
Okay, so daripada Syakir Ramli.
Or in examination, what is the marks allocate for solving redox equation? Okay, from my experience, so the mark were given is first mark is reduction, second mark is oxidation, third mark is overall equation. Okay, thank you.
Dah
So,
bersedia untuk SPM nampaknya.
okay.
Okay, alright. Soalan daripada Alan Tang semula. Okay, dia dah betulkan soalannya.
Oh, actually, what is a boiling point, right? Boiling point is when the vapor pressure in the liquid, vapor pressure of liquid is equal to atmospheric pressure. So we call boiling point achieved. So if you measure, right, usually we measure the temperature of the liquid. But I didn't discuss. I didn't discover the how about temperature of steam. So I think temperature of steam, right? We must measure in the lab or in the certain apparatus or experiment set up. It's not simple like measure the steam. Yeah, I think it's influenced by a lot of factor. Okay, hopefully help you to answer it.
Okay, the next question from Tiban Raj.
Okay, so for redox balancing, right, I think you can balance, put the phase on the reduction, oxidation, and the overall. Because they want just like not enough space to put it. So you can put it reduction, oxidation, overall, you can put the phase. So usually it's aqueous, and then the H2O usually is a liquid, and the Cl2 is usually is a gas, like this.
Okay, alright. So Safia Aisyah.
Okay, Maiden, how to know is it pure or iron or not? Okay, so how you know pure or impure, right? Is they will give you the terms iron ore RE is stand for by the visit tima visit C. So once they contain the ore, right, actually is represent inside contain the impurity and the pure iron or pure metal. Yeah. So usually they will give you iron ore or give you the metal ore. This why you call this is inside is include the pure and impure. So usually right, if you want to know whether they're pure or not, usually they will say just iron, iron ore. So usually it's a purely.
Okay. Okay, soalan seterusnya.
Alright, it's impossible they can ask you about pure metal, pure copper, pure metal. It's a possible, but the question give you must experimental. They can run an experiment. It's possible to run an experiment so they can get the data. They can ask you. Yeah, so anything can be possible, but depends to whether they can run the experiment set or not. Yeah, common is iron iron.
Okay, so soalan daripada Viroshan.
For the final percentage, 2 decimal place will be final usually 2 enough already lah. Because just now already 4, right? 4 also. Yes.
Okay. Soalan seterusnya, Hong.
Is that the number of mole for ionic equation is the same with the number of mole substance in the chemical equation? Because sometimes the reaction may include with the two substance may have same ion. Is it your mean like the just now your friend asked Cl2 becomes the Cl minus and Cl minus? All right, so no matter how, you must make sure you divide by 2/2 equation. From 2/2 equation, right, you balance the redox. Balance the common mole and the redox is different because you include the electron, you include the H plus, you include the O H2O. So if you redox, follow the redox. Okay.
Okay. Right. Mikael Hakimi.
Madam, can we find a mass of iron if a mole is given? Of, of course can. Of course can. If they tell you this is a mole for the pure, so of course you can get the mass already. But if they say if Fe2 plus Fe is like not pure, so you can't get the mass more of the iron from the impure. You must using the titration. What's the function of titration? Is using the more of the dichromate to determine more of iron 2 plus. Yeah. Okay. If they give you pure, it's okay, no problem. Means the gas like nitrogen gas upon boiling
Okey,
point
soalan
today.
daripada Alan Tang semua.
I think Valentine, we need to check the data about boiling point of the nitrogen because different gas, different boiling point. You can turn the book, international book, the behind one, the appendix, you can check what is boiling point for the nitrogen gas.
Okey, so soalan seterusnya Jonathan.
Yes, triple simple. All right. Okay, come. Writing the ratio, reactant, and product, right? Okay, first one, here we call setara. So the first equation, right? 1 more dichromate with 6 more iron 2 plus, you must put the triple symbol one because the triple symbol is meaning like setara. So then the last answer, right? You put equal because they want just equals to what answer only. So compulsory write the triple one in your exam.
Okey.
All right. Okay. This question, like the 5 step taught by Madam, can be applied in any redox balancing. Quite right. Said okay. So this is I teach you the 5, right? Is basic for the basic for all. But for the basic, right, is you get one more extra step. Okay. Maybe moderator I show the one slide how to balance basic can. Okay, I show the one slide to show the basic can. Okay.
Okey, kita tengok semula slide.
So this is this one is all about balancing the acid. Until here, balancing the acid. But if balancing the basic condition, right, is the same until here, but followed by 3 steps. First one, check the number of H. Second one, add the number of H minus at both sides. Last one, combine become H2O. So I show you one method to do the basic solution. So I repeat again, for basic solution, it's starting from the 2 half until here. Now you can check number of H plus. So here is a 14 H plus, right? So that means that you must add 14 H plus on your you must check 14 OH minus at both sides. So you plus the 14 OH minus at your right and left and right side. Okay, left and right side. Then you combine the H plus OH minus become H2O. So I will combine the 14 H plus and 14 OH become the 14 H2O. Okay, now you can check your H2O. Here is a 14, here is a 7. So you can 14 minus 7. So the balance is a 7. So that means your final equation for basic is 7 H2O plus Cl2O72 minus plus 6 Fe2 plus produce 2 Cl3 plus 6 Fe3 plus 14 OH minus. So usually, right, the basic condition, you will left answer in OH minus. So meaning that for basic condition, it's the same, but you got extra 3 steps. Okay, thank you for moderator.
Okey. So harap dapat jawab soalan pelajar ya, harap faham. Okey. Okey, Kai Kim Minji, soalan lagi.
Okay. Was it really necessary to categorize the half equation to reduction oxidation, and we can just write down the half equation? Just some lecture want us to categorize, some say it wasn't necessary. Okay, for my experience, you need to write reduction and oxidation at the beside before you balance it become one equation. Yeah. So
Okey. So soalan seterusnya.
For the
Nur Khairi.
okay. Molarity is I got 0.0516 molar.
Saya kena
Molarity.
buat pengenalan sekarang.
Okay. Molarity. Alright. I didn't count molarity. Okay. Okay, I didn't count molarity. You can check again molarity. For example, I got 0.05. Oh, okay. Means you can say 5.16 times 10 minus 2 also can. Yeah, it's okay. It's okay. The answer is okay. Yeah.
Okay, daripada Chang.
When calculated, if you get, how should we handle them before the final answer? All right, so maybe you can write the answer 2345.67856, and then you can rewrite again like 2345 point usually 0.7 like this. You can simplify like this. Or can say 2.345 times 10 minus 3 also can. So you can write the original and then you can write the four significant one. Okay.
Okay. Soalan daripada Danish Amir.
All right, Danish, just now, right, before I start the experiment, I using the Fe. So Fe will dissolve in acid, become Fe2 plus. So one more Fe will become one more Fe2 plus. Once I know the more of Fe2 plus, I will know more of Fe. Yeah, so because students already confused, teacher, I want to calculate mass of Fe, but I get the more of Fe2 plus. Make it confused, right? So actually, the more of Fe2 plus is equals to more of Fe. Yeah. Thank you, Danish.
Okay, so soalan
Boiling
seterusnya.
and evaporation. Okay, evaporation is let's say it happen at the surface. So boiling is include the all system. So you can see the boiling, you can see the bubble inside the water called boiling. Evaporation just at the surface only. The surface molecule will evaporate, become the gas. We call evaporation. Yes.
Okey. Jadi sementara tunggu soalan lagi. Okey, suka untuk saya ingatkan pada pelajar-pelajar jangan lupa untuk like dan subscribe page kita, okey, Magic Revision. Sebab kita ada beberapa siri dan siri satu ni pun kita ada lebih kurang 4 slot ya yang akan menyusul selepas ni. Okey, so senang untuk anda dapat notification nanti ya dan untuk program-program susulan. Okey, dan jangan lupa juga, okey, kami share juga link untuk soal selidik. Okey, jadi untuk buat penambahbaikan. Jadi bantu kami untuk bantu anda. Okey, jadi soal selidik itu untuk memperbaiki dan untuk melihat apa lagi keperluan yang pelajar perlukan melalui session perbincangan kita di sini. Okey, so jangan lupa dua perkara. Okey, like dan subscribe kita punya page Magic Revision, dan kedua jangan lupa untuk klik dan jawab soal selidik. Okey, untuk kami memperbaiki lagi kaedah penyampaian dan mungkin ada tajuk-tajuk yang pelajar request untuk dibincangkan dalam siri-siri yang akan datang. Jadi kami akan cuba untuk memenuhi permintaan para pelajar. Okey, alright, nampaknya kita sudah pun mencapai kita jam 10:05 dah. Okey, dan soalan pun dah. Okey, kita stop dah soalan. Okey, so pelajar jangan risau, kita akan ada lagi siri-siri akan datang. Okey, terima kasih atas sokongan para pelajar. Okey, dah nampak dah ada yang dah mula minta chapter 5. Okey, we will try our best. Okey, kita akan cuba sedaya upaya sebab page ni adalah untuk anda. Okey, kita di sini adalah untuk membantu pelajar bersedia untuk menghadapi PSPM 1. Okey, jadi kita akan cuba memenuhi semua permintaan pelajar. Okey, terima kasih Nur Afika sudi mendengar sampai ke akhir. Okey, diharap perkongsian dua tajuk dalam kimia, okey, SK 015 ini sangat membantu pelajar. Okey, tak kala kita berada di rumah masing-masing, jadi kita tak ada alasan untuk tidak mengulang kaji. Okey, kita ada banyak platform, so gunakan sebaik yang mungkin. Okey, so terima kasih kepada moderator hari ini, Puan Lim. Okey, penceramah kita Madam Iyun dan Puan Chia Chuping. Okey, dan saya Puan Nashima. Okey, sehingga kita berjumpa lagi dalam slot kedua, siri pertama. Dan saya serahkan pada Puan Lim. Puan Lim on mic on.
Sorry. Okay sorry saya lupa saya off mic. Okay, so hopefully you dapat banyak ilmu yang ni daripada Madam Chia dengan Madam Tan. So hopefully you boleh mengaplikasikan ilmu-ilmu ini dalam peperiksaan nanti So kami menanti anda untuk slot yang kami akan datang pada minggu depan. So jangan lupa, so pada masa yang sama kita berjumpa lagi. Okay, so sekian, terima kasih. Okay, bye.
Bye-bye.
Bye.